Okay, what I have up here is graph sine, cosine, tangent, inverse functions. We've already graphed them in the previous video, but what I want to show you here is domain and range. Now, we'll talk domain, and usually domain is what we care about, but actually it's range that we're going to really need to focus in on when we calculate these inverse functions. So, if you look at this graph up here, as far as domain is concerned, for sine inverse, you can see your domain is going to run from -1 to 1. And what that basically says is that you can't input for x any value, greater than 1 or less than -1. And we saw this before. If, for example, I say, okay, what's sine inverse of 1.5? I mean, you can try that on your calculator all day, but that's an issue. That will never be able to be calculated. That's a domain error because sine inverse does not include this value in its domain. So, like I said, we've run into that before when we were doing laws of cosines, laws of sines, when you had to do an inverse and you'd get a domain error, we'd say, well, that triangle maybe doesn't exist, right? Well, same idea here, right? So we can just do the domain of this one, or you can see it is also -1 to 1. It's kind of interesting about the tangent inverse. Your domain, domain is all reals. Left to right, it's negative to positive infinity. Right? So, very different domains for these particular functions. But what I was saying is it's the range that we really need to focus in on when we calculate these inverse functions. So, let's check out the ranges. If you look at the range for the inverse sine, it was the restricted domain of the regular y equals sine, which was -pi12 to pi12. Okay, the range for cosine inverse, if we look, it goes 0 to pi, both inclusive. And for tangent, well, it goes -pi12 to pi12, but we can't include those values. So we have to use parentheses, -pi12 to pi12. Now, the reason we care about the range is we are looking at what the output for these functions need to be. And it really describes the quadrants, and that's what's important, the quadrants where our answers can be located in, right? So, for example, when you do an inverse sine, your output can't be quadrant 3, for example, because that's out of your range. We're running from -pi12 to pi12. That's only, if you think about it, -pi12 would be 270, if you think of it that way, up to pi12. That could only be in quadrants 1 or 4. So let's kind of extend this thing out. So this is the graph of sine inverse. This is your domain and range. What this means is if the x value, your input, is positive, that means your answer or your output has to be, let's put it this way, if x is greater than 0, then output will be in Q1. You'll get an output in quadrant 1. Draw an arrow here. If your x is less than 0, in other words, if your x value is negative that you're substituting in, then output will be in Q4. And your output is going to have to be a negative angle to fit within these bounds. So, if you think of a quadrant 4 angle and you're thinking in terms of a positive angle, like, for example, just throw something out here, 290 degrees. Talking 290 degrees, that's what you're going to get as your output. That's not correct. What you're going to get as your output is a negative angle. So instead of 290 degrees, we're talking -70 degrees would be our output. Right? So when you do an inverse sine of a value less than 0, you're not going to get a huge angle like this that's in quadrant 4. You're going to get a simpler version. Just go the shorter direction. You will get a negative output value. Because of this, it's really saying, really, I shouldn't write this, but I will. It's saying our values for our output has to be between negative 90 and positive 90 inclusive. Right? So we do have to go to the negatives when we are inputting a negative value. So if x is less than 0, then the output has to be in quadrant 4. Now, as far as clearing this thing up, hopefully, what we can say is, for an example, I can fit this in. If I say, what is the sine inverse of, let's go square root of 3 over 2. Now you can enter this into your calculator, and we'll see in a future video here shortly that we'll calculate this. But if you go to your calculator and do the sine inverse of exactly the square root of 3 over 2, what you're going to get, if you're in degree mode, you will get 60 degrees. And we'll explain why. The reasoning we'll get to as far as the inverse is concerned in a future video. When you go to sine inverse, and then instead of positive square root of 3 over 2, you use negative square root of 3 over 2, it's not going to give you a quadrant 4 angle that's positive. It's just going to go to the negative version of this, which would be negative 60 degrees. You would actually get a negative value of the positive version. So it's really not that complicated as far as the difference between positive and negative, at least for inverse sine, because of how the domain and range are written. Now, when we go to inverse cosine, we're going to do the same thing. It's all about the range. We'll say if your x is greater than 0, x is positive, then your output will be in quadrant 1, just like sine. So, quick example of such a case. If I say, okay, what's cosine inverse, and we'll stick with the square root of 3 over 2. You should recognize this ratio, and it'll make sense why this is actually what it is. But the cosine inverse of the square root of 3 over 2 will be 30 degrees. And like I said, go to your calculator, hit the cosine inverse of the square root of 3 over 2, and you will see it is 30 degrees. Right? If x is less than 0, then output. Now here's the tricky part. If you look at your range, you're going from 0 to pi. That's 0 to 180 degrees. Well, you're going to be in quadrant 2. So the idea is cosine is negative in quadrant 2. It's positive in quadrant 1. Why don't we do that for sine? Well, sine is positive in quadrant 1. If we went to quadrant 2, sine would still be positive. We needed to go to quadrant 4. So it's also how we restricted the original domain. All right, so for example, it's a little bit trickier. If you try the cosine inverse of negative square root of 3 on negative square root of 3 over 2 on your calculator, it's not going to give you negative 30. It's quadrant 4. Cosine is actually positive. So we have to go where cosine is negative, which is actually quadrant 2. It's going to be a reference angle of 30 degrees. Well, if you think about quadrant 2 reference angle of 30 degrees, I'm going to have to erase this here momentarily. A reference angle of 30 degrees in quadrant 2 indicates that your calculator should give you 150 degrees, which it absolutely will. Do cosine inverse of negative square root of 3 over 2, and it will say 150 degrees because it has to be a reference of 30, but you have to be in quadrant 2. Cosine is one of the more painful ones. Sine and tangent work very similarly, but cosine, it's a little bit different when you have to deal with the negatives. All right, as far as tangent is concerned, again, it is all about the range. So we'll say if your x is greater than 0, then your output, will be in Q1. In other words, if I say, okay, you won't see tangent inverse of square root of 3 over 2. I mean, we could do that, but it's not going to be a pretty answer. So we're only interested in the ones that are going to give us a nice looking answer here. So I will say, what is tan inverse of, say, the square root of 3? Well, the tangent inverse of the square root of 3 is actually going to be 60 degrees. Okay? And you can see that on your calculator. All right. If x is less than 0, then output is going to be in Q4. Very much like sine, and very much like sine, we're going to have to go with the negative angle. So if I say, okay, what's tan inverse of negative square root of 3? It's simply going to be a quadrant 4 angle, same as this, but the opposite. Doesn't make any sense. It's the opposite of your quadrant 1 angle, so it'll be a negative 60 degrees. Right. Now, in the next video, we'll talk about how we actually calculate these, and it's just going to follow the pattern that we did for normal inverses, but this is, a little bit more involved. So make sure you have this down. This is extremely important to know to make sense out of what we're about ready to do.